So this next project I want to work on is I've got this dive tank. It's an aluminum dive tank that a friend of mine at work cut the bottom off of, and you'll notice there's a ridge in here. So I'd prefer not to grab it by a piece of pipe stuck in the nipple side, but there's no real easy way to grab this small bit here. I want to ultimately remove this side, but first I need to be able to grab it with the jaws here, and if you'll notice this sloping bit here, that's because the way these are made is they're heated. A slug of aluminum is heated until it's plastic, and then it's pressed into a mold. So the inside is by no means equal thickness all the way around, and the bottom slopes in. This is actually the bottom he cut off. I've removed material off it. It's actually much thicker than this. It's pretty impressive, really. Over an inch thick material on the bottom. So the first thing I need to do is get my steadyrest, get this thing centered in here more or less, and then I need to take my boring bar in here and just make a flat surface so I can turn this guy around, put this end over here, and get it in the jaws to grab on the inside. Then I can part this end off and once again bore it out, and then put threads on it. And I want to put threads on this piece, so I basically want to make it a flat end. And then this whole thing I am going to mill some slots in it to create different width leaves, and those leaves will ring. I'm going to put a brass ball down the middle that will hopefully ring nicely, because right now it rings wonderfully. My complaint is I'm not a big fan of this round top, and I know most bells are round, and maybe it's a mistake, but I'd rather have the top flat. So that's what I'm going to do. So the first thing I gotta do is get this guy centered up in here. Let's do that. So while I'm trying to align this guy, notice how far out it is. I'm thinking, why can't I get this positioned right? It's actually here. If you look at a reference point, look at this edge right here relative to the side of this, and you will see that this thing is not even a little bit round. Holy cow, had no idea. So we may have to turn it out around and make a round spot on it, and then turn the whole thing down to try and make it equal. Not that it has to be, I just like it to be. Wow, that's insane. I can't believe how far out it is, like a 1/10 of an inch. Yeah, I'll see if I can dial it in a little bit closer, but I don't know, because if I go from here to here, it's dramatically different. The bulge is different. Look down here as it goes. It's not even close. So we're going to see what we can do, but we're going to run this really slowly. So I did realize while I was trying to adjust this, that as I adjust front and back, I'm pushing this up, and this is going up and down, so this thing is tilting like this. So my lathe is flat within 1/1000th over an inch, a little bit under that actually. So I went and adjusted both the front and the back until this guy was more or less level. It looks like I still need to drop just a little bit here. It might be. The problem is this thing is not flat at all. So you can see it rocks sitting there. So we'll get that close, and I'm going to try and get the dial indicator just a little bit closer, and then we're going to try and turn it. So I can't tighten any bearings on this guy, so if I take more than the lightest of cuts, it of course does not work. Even a really light cut of like 10/1000ths is bouncing all over the place because it's such a huge lever arm off just a piece of 3/4 inch pipe. So I may have it flat enough I can grab it in the 3-jaw chuck and then try and turn the whole side so that it's at least flat. So we're going to try that next, since this has not been terribly successful. Crazy. There she blows. So we were able to get it flat enough to get the jaws in there. Ugly. It's got a nice bite on it, and my center just barely is able to hold that. And this thing's so out around, it's going to be a terribly interrupted cut. So let's just see how it works. And and this thing's not flat all the way across, so it might start taking big bites as it goes across. I don't know. We're going to start with 10 thousandths. I think before I go, I think I'm going to need to take the feed rate and increase it a bunch. 7 thousandths a revolution. Because until I'm able to make this round, I can't really use the steady rest to fix it even more. So we're going to give it a shot here. Oh, it seems like the biting deeper. Because I don't know where the, yeah, it looks like there's a big hump here in the middle. Hopefully that won't be too big a bite. Keep our eye on it. I have a suspicion that every time this was filled with air and then decompressed and recompressed to 20-some hundred psi, that the aluminum slowly became deformed, because I know that over their life expectancy, they only have so many refill cycles they're good for, and then they're retired. So it's probably because of all the expansion and whatnot, because this is terrible. Significantly more than 10 thousandths of an inch cut down here. Looks like closer to 100 thousandths interrupted. Wow, is that so far out down at that end? Holy cow. It's still like 100 thousandths out. We're going to have to do many more passes, I think, in order to even get close to this. Closer to continuous. Wow. Pretty darn close to continuous. That's impressive. At least on this end. The other end is not going to be so good. So this is a cleanup pass, although I realized after I did this that once I put the steady rest back on here, it's going to put a nasty old groove, you know, mark on there that I'm going to have to take off. So what I'm going to do is, after this completes, we'll turn this around again, we'll finish that end, we'll flip it around one more time, we will part off this rounded side over here, thread it, thread the other piece that's going to go in there, and then I can hold that between centers and run another pass over the whole thing to clean it up, to get rid of the damage I'm doing. Anyways, that's the plan. I just couldn't leave it with this finish, even though it's not terrible, but I can feel it with my fingernails, and aluminum finishes so nicely, especially with a positive insert cutter like this. So we're down to 3.3 thousandths a revolution and 300 RPM, which is about the top of what I feel like comfortable with. I mean, it seems pretty stable, but this is a big piece, and the inside is not consistent at all. The inside is as out of round as the outside is, so this is not an even weight, it's not an evenly distributed mass rotating here. So faster you go, the more exaggerated those effects are going to be. So I think this is about it. Just means you gotta take it slowly. So I forgot about the chip deflector I made. I was getting little fuzzy chips everywhere. So just sitting on a Noga clone base. It's a brush with just a little piece of metal rod taped to it at this point. So anyways, it works reasonably well. Keep it off the floor in front of me. So a little bit unexpected. If I'd known better, I would have expected it, but I didn't. We now have the outside of this at least cylindrical, but it's not coaxial necessarily with this, because this is threaded and you never know how the live center is going to sit in this. So I've switched to a 4-jaw chuck so I can line that up properly. We're going to get the steady rest back out. We are going to bore the inside of this so it's parallel and coaxial with this with the outside. Then we're going to flip it around, re-indicate it in, and we're going to part off this side. And then I'm going to measure the inside. I'm going to bore it out also so that it's cylindrical, because the inside of this isn't any more cylindrical than the outside. And then I'm going to measure it so I can figure out what size threads to use. I'm not using anything on the machinist handbook. I'm just going to choose something like 10 threads per inch, figure out what my major and minor diameters are going to need to be based on this diameter, and go from there. So we got the 4-jaw chuck in, we've got the 3/4 inch pipe back in. This thing is now round enough that I can actually tighten the top of the steady rest without it having binding. It was oval before. Well, it had bumps. It wasn't oval, it was bumps. And so it would come around and the bump would catch if you tightened it all, which meant I couldn't bore anything. So this isn't bad. It's off by a few thousandths out of round like 6 or so, 5 or 6. So now we're going to take a boring head. We're going to go in and try and rebore this again and get it flat, and then flip it around and part off this guy right here. And then we'll hold it in the steady rest, and we will go from there. Yeah, we're going to have to thread it in the steady rest. There just isn't a good way to do this. That's very interesting. All right, let's get going. So it turns fine now in the steady rest, but look at this head on. It is not even thickness all the way around, not even close. Pretty amazing. So we're going to try and make it close. I don't know how thin it's going to make it, but we're going to try to make it coaxial with the outside. So the first one was a 50,000th depth of cut. The second one is a 50,000th depth of cut. Extremely interrupted cut. I forgot to face this, so I'm going back and I'm facing it first because I hated the way it met in the beginning. You can see how out of round it is. This is a 50,000th depth of cut. My third 50,000th depth of cut. Now we can go back to what we started with, which was boring this thing out. Even after taking off 3/10 of an inch from the inside diameter, there's still some spots that aren't cleaning up. Pretty amazing. But I think this will be fine for the jaws biting. It's actually not much more. It looks like maybe in 1 or 2 more passes. There's a fair amount of oscillation. Can't get a clean cut on this thing at all. I don't know if having the steady rest closer to here would help, but we're going to flip it around and part the other side off and then do the same thing to the other side. Alright, so we're getting ready to part this guy off. Oops. So there we are. Let's see how this works. It's still a few thousandths out of round. Taking it slow because I'm pushing directly against the bearing. That's how thick the material is. So first we're going to face this side, now that we've parted it off. Then we're going to bore the inside and see if we can make some semblance of round, but you can see it going up and down. It is definitely not coaxial at the outside. And once I get that cleaned up, we have to switch over to this piece and thread this piece first so that I can test it inside here, because if I thread this, it would be really hard to pick this whole thing up and put it on and test the thread. So put it on, take it off, put it on, take it off. You know how it goes. You know, the other possibility is I did have this all very round the other day and it was skimming. I wonder if skimming off that 1/4 inch of material off the outside release some tension, and then this thing overnight changed shape a bit. Could be. Because it's not completely round today. This thing's fighting like a 3,000th bump, or 2 or 3,000th bump going up and down. Alright, so back to boring out the inside. Back 50 thousandths. So here we are so far, and I ran into a bit of a hiccup. So I had put this in the lathe and turned the whole outside of this down about 1/4 of an inch, and it was round. The last pass was like a 10,000 skim pass, and it was a nice even pass of the whole length. So I knew I had it round the day before. So the next day I popped it in the 4-jaw chuck, tightened down the steady rest, and I couldn't get a finish to life me. And this is at the end. This was the worst. It's actually a little better on the other side. What had actually happened was I noticed when I was dialing it in that it was about 5,000th out of round, and that should have been my big warning sign right there, because it should have been perfectly round, but it wasn't. And when I tightened the steady rest down and tried to keep it going in a nice round circle, it split 2 of my bearings on the steady rest, which they're good for 650 dynamic pounds of force a piece, so shouldn't have been a problem, especially since I'm only hand tightening these, and I really wasn't cranking on it either. So well, I think what happened was that the last skim pass made it round like it was without any problems, but then all of the tensions built up in this aluminum, not only from the manufacturing process, but potentially from all the filling and unfill cycles this air tank went through. You figure you put 2,000 psi in here, and there's hundreds of square inches, you know, you've got quite a few 100,000 pounds force pushing out in all directions on this bottle when it's full. So that was my mistake. I should have noticed when I couldn't get it round that was going to be a big problem, and gone back and just skimmed a section. So that's what I'm going to do. I'm going to put this back in the 4-jaw, let one end just rest on the steady rest, skim a section flat, round, so that the steady rest will have something to ride on that's round. Hopefully it'll stay that way. And then I got to clean up this inside because it's a mess. Get my final diameter before I thread it, and then I can go on to make this thing the right diameter and thread it first, put this guy back in, put some threads in it, and use this to test those threads. Since the threads I'm going to choose, I'm just going to choose 10 threads per inch, but it's, you know, this diameter is not in any of my books, so in machinery handbook, so I'm just going to make something up for it. So anyways, and then I'm going to have to finally, once I get this thing back in, screwed in here, then there's going to be a hole in the center of it, and I can put one end in the 4-jaw chuck, the other end can be in my steady rest over there. I mean, not in the steady rest, but in the center, and then I can skim the whole outside of this and fix all the bearing marks. So that's the plan. So I made some more discoveries. I have to indicate over here to get center, because if I indicate here, everywhere the jaw is a high spot. Even if you're not really cranking on it, I didn't think 1/2 inch thick aluminum would have that problem. I mean, seriously thick. But even without really cranking on the jaws, it's deforming the aluminum. So I had to move over here to get center. So that's one of my problems. So I am going to machine, without supporting this end at all, a flat about this wide. I'm just going to go in a few thousandths, be very gentle, use a positive rake insert, and give myself something for the steadyrest to run on that is round, and then flip this 180 and see if I can actually turn any of this. So that's my goal. One thing I did do, just for safety's sake, is stuck my steadyrest in the end of this just in case it fell off. I've got it extended inside a bit. Just don't want this thing going anywhere. This is pretty low stress, but you get the my paranoia, because this is huge stick out. So. Alright, so I've done two things here. I've remachined a flat spot here, and I have also put a spring behind this guy so that there can be a little bit of give. I don't know how well that's going to work. It's a pretty stiff spring, so I'm hoping it'll be alright. What I'm trying to do is to have it get so it has a little play, so that it won't break the bearings if it goes out around on me. But right now it's about 1/1000th, so I think we'll be good. I'm going to give it a shot, and I'm going to try and clean up this inside part first, and then we will move on. Then I can take a measurement and we can move on to the next step. And for now, looks like we have success. .310 according to the caliper. So next step's going to be to bore a 1-inch hole in the center of this guy for an arbor, because I'm going to need an arbor to turn the outside dimension and thread it. So we're going to start by drilling and then boring for 1 inch, and we're going to go for 7/8, and yeah, we're going to stop at 7/8. So I might as well just get started. Thousand steps for cuts. And another 100. Thousandths total. That should put us at about 825. I need to measure that, of course. Doke. Okay, nice chamfer on the backside. Now we need to create a flat spot because the arbor is going to come through here, and then I'm going to put a washer on this side and you know, put the bolt through that so that we can turn and thread the outside of this. Because we got to turn this down, we got to take like almost an inch off, and so now we're going to look for roughly zero, and let's square this up here. So let's see where this one. Okay, there we go. That'll work very nicely. And for completeness, let's relieve some edges. Nice. So now we've got to make the arbor, and well, boy, that's still sharp. I'm going to take a little more off that. Then we're going to make the arbor next, and mount this on it, and then turn this guy. Bring you back. Ugly and very hot, but works all right. Chip breaker's not really working. I think my feed rate's too low. This is 3/1000ths a revolution. Oh, nice. Alright, we're going to change our feed rate next go around. See how 7/1000ths a revolution works with 200,000th depth of cut. Better. Chip breaker's working now. Really light pass. Give a gentle chamfer to that edge. Sorry about the fan noise. It is hot and very humid today. And by very humid, I mean 50% humidity, 80 degrees. Oh, that's that's a great fit. Okay, I made it a little bit lower than the outside so that it would be able to pull tight. So we got a nice big flat to pull against, so now we got to drill and tap the center. I think we'll do 1/2 inch. Drilling and tapping for 1/2 13. So we got this guy mounted on an arbor with a flat on the back to support the back. The inside 7/8, the back is like 2 inches. And so we're gonna chuck this up. We're gonna turn down the outside dimension and thread. So we're gonna be bold and take 100,000 steps to cut, see how it works. Double the feed rate, chip breaker starts working. Ow, are they hot? Boy, you get in your shoe. Oh, hurts, don't it? Last pass. Sorry about the fan, but it is really hot in here. Right on the money. We're setting up for threading here, and making sure we're square to the part. This is the thread gauge that I took a little bit of material off the top because it would hit the relief here, or the flat spot on the cutter. I don't know if that's actually relief. Before it would seat. Now it seats nicely. So just got to tighten this guy up, and we're good to go. Alrighty. That's a bit far out. I think after this one we're going to reduce the depth of cut a little bit. That's surprising. Let's do one more. No infeed. For spring pass. Took off a surprising amount of material the first time through. So here's the finished plug on the arbor. I'm going to leave it on the arbor. It'll make it easier to thread it into the other side. So we got this guy back in the 4-jaw chuck on the lathe, and we had just cut the inside of this round just last time we had this mounted, and it's already gone out of shape a bit, as you can see. With the wavy up down sort of pattern. So we're going to try and thread this, but it might be challenging. So I'll bring you back. Right, so this is way out of round already, but we're going to try it anyways. So we're going to do a pass 20 thousandths. All the settings are the same. And I got to remember to take the compound the opposite direction from where I normally go, because I'm pulling back, not pushing in. Pull numbers. Might as well give it a quick look, see if it's okay. Very nice, good fit. Didn't expect to change since I didn't change the settings on the on the lathe since I did the other threads. So we'll find 0 again. And we'll go 10 thousandths. This. Those threads are starting to look good, definitely. Let's reset this to 0. Holy moly. Nice. I guess I gotta just chamfer. Did not expect that. So we got this guy loaded back in here. I'm using that end piece I threaded in with the center and then the chuck, 4-jaw chuck holding on the other side. And it's not bad. It went in pretty darn straight, really. We might be able to take this out. So we're going to try and get that adjusted a little bit tighter. And then we're going to take skim passes to remove the major imperfections off this. That's just lovely round, isn't it? Alright, so let's go for 25. We're going to speed this up. We'll go one up. We're going to go for 300 RPM. I think this will be fine. We're hitting our first bearing mark. So far, so good. Alright, so we're done. You can tell where the bearings were a little bit, so I must have just barely got the bottom of it, and some parts might have been just into the section I did. So maybe if I'd done 30 thousandths, I would have got a perfectly clean pass. But in any case, then down here is a little spot where some chips got stuck. And anyways, that's minor. This is going to be out exposed to the elements. So let's see if it rings and how it rings and whether or not we decide to put some slots in it and divide this up into leaves hanging down. So it's got a decent ring, but I think if I cut slots in it, it will lower the frequency of some of the rings. Plus I can have 2 or 3 different notes. If I divide it in half and then take that other side and make it 1/3 and 2/3, I'll have 3 different notes. So as a solid piece, this guy rings at a pretty high frequency. That's because it's one solid piece, so it's structurally very strong, so it keeps the resonance frequencies pretty high. So I'm going to put some slots in it. First I'm going to divide it in half. I'm going to go from about, I don't know, 4 inches from the top, and I'm not going to cut all the way through the end. I'm going to leave a little bit so that it'll have some strength when I flip it around, and I'll have to manually cut that out later. So I've currently got it clamped in both sides. I've got a little piece of protective aluminum there, and this one I just clamped right on it. And so yeah, we're gonna cut all the way through, and we're gonna start with cutting it in half. And I'm gonna leave like the last, I don't know, 3/8 or so on the end here as is. Higher RPM seems to work better. This is 2000 RPM. Yeah, that's working a lot better. So we're switching to a 3-flute to see if there's a little less vibration. I'm not sure that it will be, but I thought maybe more cutters engaging will smooth out the power, you know. 2 cutters that's hitting twice, you know, with a gap, and maybe this way it won't be. I don't know. We'll see if it's smoother. It's a test. So I think it's actually worse. So we're going to go back to the 2-flute. All right, so we made it all the way through one side, and we left a little tab on the end for strength and sturdiness. This thing's vibrating like crazy. I can't imagine how hard it's going to be to do the other side, and I don't think there's any chance I can do the extra one I wanted to do. So we're going to flip it over and see how that one works. I'll bring you back. So I used my vise stop so I didn't have to find my 0 point again on this side. So we're going to try the other side and leave a little pip again just for stability. I think it's going to be ugly. It's going to vibrate more than the last one, but we're going to give it a shot. And I might have better luck if I went to a smaller diameter cutter, but then it'd be more prone to breakage, so I don't know. Sort of a mixed bag for me. So we're going to give it a shot and see how that works. Then we'll cut the pips off and see how it rings. So I have no idea why, but first pass it's working out okay. I should knock on wood. I'm probably cursing the works here, but first 50,000 steps of cut is working surprisingly well. So there is vibration. I'm at 2000 RPM and I've got a fairly fast feed rate. So just keep my fingers crossed. We'll see how it goes. So on the second pass, a different type of vibration. So what I did was dialed in the speed to get the vibration I was looking for. The second side went really well. I even cut all the way through at the end because I figured I'd only have to do sawing in one half that way. And the moment I cut that last little bridge, I did like 25, 30 thousandths at a pass. It popped apart, probably 50 thousandths. A lot of built-in tension in this tank. So everything I was seeing while I was turning it on the lathe is being demonstrated again right here. Very interesting. All right, I'll bring you back. So she's finished. It was a great time to use the big steadyrest, and it was a nice challenge because the material had a lot of built-in tensions. It was really larger than anything I've turned on my lathe so far. It was challenging to do threads of dimensions that weren't in the machinery's handbook, so I just had to use major and minor diameters to calculate what threads I'd use. As for the sound of the bell, it's not the greatest. So not really pleasant. I'm going to look up more about how you design resonant features into bells, but at this point it's not great. It rings, but it's not terribly pleasant. So we'll see what we can do about that. Maybe there's nothing, but it was a really interesting experiment. So we're done, and I hope you enjoyed it as much as I did. It was a big learning experience for me, and hope to see you next time.